I hope that you're using this video after you have attempted the problems, just like it says there, because it's very important that you try these first and then see how you did before you try to jump in. And then what that's going to do is cause some questioning that you might have for yourself, and then you'll hopefully get it answered. If not, though, write down your questions and make sure to ask me in class tomorrow. Okay, I'm actually going to start with numbers 2 and 3 first, just because they're a little bit easier. But when you're working on these and it tells you what to do here, what you want to focus on is the definition that was given earlier. So anything that goes down is going to be the function minus some value. Okay, so in this case, the function is this stuff. Okay, so we're going to replace that there. So our new function is going to read, and you'll want to, it's telling you up here to use g for your new function. So it's going to look like g of x is equal to the function, that's the entire function there, f, and then it says 6 units down. So down we know is on the outside of the function minus 6. So we're going to do this. So what that means is that our final answer can just be simplified in this part. So the final answer to this is g of x is equal to negative absolute value of x plus 9, and then just minus 7. Okay, so we took the function that was there and translated it 6 units down. Okay, let's try the next one. It's very, very similar. I suggest you pause and then come back and look at it later. This is going to work the same way because it's 7 units down. So I'm going to start with the function. I'm going to call my new one g. The original function is negative 2x plus 2, so that's my original f. And I'm going to show that it's going to move 7 units down, and then anything I can simplify I will. So in this case, g of x will be negative 2x minus 5. Okay, so that's the answer for that one. All right, so now let's go up. This one's just a little bit different because it's on the inside, and so anytime we have the inside, we have to do something extra. All right, so let's go back to what units left mean. That means you're taking the function and you're plugging in x left would be plus, so x plus some value. So in this case, that value we want to go as 2. So this would look like f of x plus 2. Okay, so what I'm going to do then is take that f that I have, so I'll do that part in blue. So my new function will look like this f, which is absolute value of 1/3, but where I see x, I'm going to have to put in x plus 2. So that would look like this. And then, so this one is a little bit tricky just because now we're going to distribute that 1/3. So the final answer for this one is actually absolute value of 1/3 x plus 1/3 times 2, which is just 2/3. I suggest that maybe you go back and just listen to that again, that just to get it, and then of course we'll continue to practice. Okay, so the next one is reflection in the x-axis. Reflection of the x-axis is negative whatever f of x is. So that's going to be easy. G of x is just going to be negative of my function. And then of course I would need to distribute my negative sign. Okay, so this is what your actual function looks like, and I'll just put a g of x. There you go. Okay, so the next one is reflection in the y-axis. Reflection in the y-axis means f of negative x. So every time I see an x, I want to plug in negative x. Okay, so that will look like 4 plus absolute value. This x I'm going to replace with negative x. And that will show the reflection in the y-axis. Okay, so the vertical shrink says, let's see, I believe that one was written as a times f of x. The vertical will be on the outside, and since it is vertical, we don't have to do anything with flipping or anything like that. We're just going to use the 1/5 as a. So we're going to set this up as 1/5, which is the a factor, times the original function. The original function is negative 5x, and then we're going to simplify. And 1/5 times 5 is just negative 1. So this actually turns out to be really nice. It's just negative x. Okay, the next one for the vertical factor, since this one's similar, I would suggest you pause and try it on your own if you haven't already, and then pick back up when you're ready. This is going to be the same thing. We're going to have our new function is going to be the factor of 4 will be 4 times whatever g of x is. So g of x is all of this stuff. So I'm going to put it in like this. Notice the parentheses. That's because it has to be put in, I'm sorry, because this is your, well, let's see if I can make it make sense to you. So it'd be like this. So 4 times f of x, and since f of x is all of this, I have to put that in parentheses because now I'm going to have to distribute. So this final answer is actually going to be 4 times the absolute value of x plus 3 and then plus 8 because we're going to have to distribute the 4 and the 2. Okay, for this set, horizontal stretch and horizontal shrink, remember that's the one that's on the inside. And so we have to use the factor of a as 1 over a. So that's going to look like, the definition for that is f of 1 over a times x. Okay, yes. All right, so since we're talking about 6 is our a, so we're going to actually use, when we plug this in, we're going to use 1/6. And plug that in everywhere that we see x. So in this case, our new g of x is going to look like this. It'll be the f, but where I see x, I'm going to plug in 1/6 x minus 9. Okay, so then that's going to be 3 times 1/6 is 3 times 1 divided by 6 is 1/2. And then just minus 9. There's no distributing here because this wasn't a binomial to begin with. Lots of algebra rules going on here. Okay, and then the last one, the horizontal shrink, same thing. A is going to have to then be the flip of this, which is 4. So we're going to use the original function. Everything else is the same, but when I get to this x, I'm going to have to plug in 4x. Okay, so that's going to be absolute value of 32x minus 4, and that is going to be my new function. All right, so what we have going on here is we have an original absolute value of x, right? A function whose graph represents a reflection in the x-axis, that means the negatives on the outside, by a horizontal stretch. When I see this word horizontal, I'm going to automatically think to flip this. This will actually be 1/3. And then 5 units down means on the outside. Okay, so that's easy. So we're going to start with, oh, sorry, this is g of x again. So g of x, we're going to do that, flip over the x-axis first. That will be negative absolute value of x. Oh, whoops, hold on. Nope, that'll be negative on the outside. The horizontal stretch is going to be the 1/3 part. And there's just an x on the inside, so that part's easy. And then 5 units down. There we go. All right, and then the last one is which transformation will not change the y-intercept. So think about this. This is just an absolute value graph that moves up 3. Okay, so what type of transformation will not change that? So I'm thinking if we flipped over the x-axis like this way, it would change it. We could stretch it, shrink it, do all these other things. But what if we flipped it over the y-axis, which is also called a reflection? In that case, we would have this absolute value that's just going to flip over. So this part becomes here, like that, and then this part becomes that, and it ends up giving us the same thing. Okay, good luck. Please go back and watch anything else because we will be practicing these, but it's important that you can get a good start. And please bring any questions to me tomorrow. Good luck. Have a great evening.